to True Projects. In this video, we are going to explain about face recognition using forward and backward neural networks. Introduction. Face recognition utilizing both forward and backward neural networks is the project's main objective. The provided photos were duplicated for training in order to get around the dataset limitations. An individual ID was given to each person's photograph for tagging. There include modules for face recognition utilizing camera input, training forward and backward neural networks, pre-processing datasets, and showing accuracy and loss graphs. The program recognizes people and shows forecasts that are more accurate than a predetermined threshold. The algorithm demonstrates the capacity to identify both known people and possibly unknown people caught on camera. With only a small amount of data, the project uses neural networks to accurately recognize faces and provide useful real-world applications. Objective. The project's objective is to use forward and backward neural networks to accomplish face recognition. Multiple copies of the same image are used to train these networks despite the small dataset that was provided. Based on the trained models, the system is built to identify recognized persons and manage unknown individuals using a prediction threshold. Dataset handling, forward and backward neural network training, real-time face recognition using camera input, and the presentation of training accuracy and loss graph are all part of the project. While performance varies, the project use of these modules show that neural networks can recognize people, and it also illustrates the viability of using deep learning for facial recognition tasks. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows only, processor of Wi-Fi and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements. In software requirements, we have Python IDLE with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is upload and pre-process dataset. This module involves preparing the dataset for training and testing. Images of individuals are collected and each person's images are assigned unique IDs. The dataset is then split into training and testing subsets. Pre-processing includes normalizing image pixels to a consistent scale, ensuring the neural networks receive consistent input. Second module is train forward neural networks. In this module, forward neural networks are trained to recognize faces. Forward networks take an input and predict the output, mapping inputs to corresponding classes. The process involves feeding the training images through the network, adjusting weights and biases using optimization techniques like stochastic gradient descent, and iteratively refining the network's ability to recognize faces. The output layer typically uses softmax to provide probability scores for each class. Third module is train backward neural networks. Backward neural networks, also known as autoencoders, are trained to reconstruct the input data. These networks consist of an encoder and a decoder. The encoder compresses the input data into a lower dimensional representation, and the decoder reconstructs the original data from this representation. The process involves minimizing the difference between the original and reconstructed data. However, it's important to note that autoencoders might not be the best choice for face recognition due to their reconstruction nature. Fourth module is face recognition. This module focuses on using the trained networks for real-time face recognition through webcam input. The steps involve capturing frames from the webcam, pre-processing the frames, and passing them through the trained networks. The network's outputs represent the probability scores for each class. The class with the highest score is considered the recognized person. An accuracy threshold can be set to ensure reliable predictions. Fifth module is accuracy and loss graph. This module is about visualizing the training process. Training accuracy and loss values are plotted over epochs. Accuracy reflects how well the networks are recognizing faces, while loss indicates how well the networks are minimizing errors during training. Monitoring these graphs help in understanding the network's learning progress and identifying potential overfitting or underfitting. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. In the dataset folder, we have the images of the persons which we have used during the execution of the project. This is the model folder. This folder contains pickle files which contains algorithm information. These files can be loaded into the project code during runtime to utilize the train models. And this is the videos folder. These videos are used in the execution, augmentation, backward, face recognition, forward. These are the Python files which are used in the code for the execution of the project. This is run.bat file. Instead of executing the project in the command line interface, we created Windows bat file to execute the project. Double click on run.bat file. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on upload and preprocess dataset to upload the dataset and preprocess the dataset. Select the dataset. So here we can see we got the total images in the dataset, and the dataset is split into training and testing, where training will be of 80% and testing will be of 20%. Now click on train forward neural networks to train the neural networks and get its accuracy. After training forward neural network, we will get the performance metrics of forward neural network. Now click on train backward neural networks to train the algorithm and get its performance metrics. After training backward neural network, we will get the performance metrics of backward neural network. Now click on face recognition to recognize a face. So here we can see that the face is recognized. Now close the image and now click on face recognition from video. So here we will select this video and then open. So here we can see this is the video which is playing, and in the video the person is detected. This person is detected as person 0, and this light green color shirt person is detected as person 1. And this navy blue color person is detected as person 2. And here we can see there is no person, but still the unknown person is also detected. And here this person, yellow color shirt person, is detected as person 3. So in this way we can detect the number of persons. Now close the video. So here in the text area we can see recognized as person 3 and prediction probability percentage. Now click on accuracy and loss graph. So this is the backward and forward neural networks accuracy and loss graph. X-axis represents epoch and Y-axis represents accuracy or loss rate. And here the green line represents backward accuracy, blue line represents backward loss, yellow line represents forward accuracy, and red line represents forward loss. Now close the graph, close the GUI, and the conclusion of the project is the project uses an extended dataset derived from provided photos and forward and backward neural networks for face recognition. With a variety of photos, each with its own ID, the models are trained. Despite being based on scanned photos, augmentation allows for the training of strong models. Dataset upload and pre-processing, training for both neural networks, face recognition with possible thresholding, and accuracy and loss graph display are among the modules. It is possible to perform real-time recognition using camera input. The backward network's accuracy is lesser due to its architectural design, while the forward network achieves 98% accuracy. The project successfully displays recognition powered by neural networks and paves the way for practical use with room for advancement. Thank you for watching the video.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.